These are the notes for AP Calculus on the topic of integration by partial fractions continued. So this method of integration is called integration by partial fractions. There's another name for it also. So if we go back to the beginning here, the other title here, sometimes it's referred to as decomposition of fractions. And it's referred to that because you're, in a sense, starting with a single fraction like this and decomposing it, in a sense, into its component fractions, into its smaller fractions. So, first thing we have to do, if it's not already done for you, is to factor the denominator. So here we look for factors of 2 times -5, -10, whose sum is -3. And that would be -5 and 2, just happens to be the same two numbers here. So then you would use those two to split up the middle term, so you can write as 2x squared minus 5x plus 2x, that's the same as -3x. We're just splitting that up. And then leave the -5 alone. Again, you can put these in either order you want. Steps will look a little bit different, but the factored form will look the same in the end. Then split in half. The way I did, the GCF would just be x. And you'll be left with 2x minus 5. Or if you switch it around the other way, the GCF would have been 2x. And then here the GCF is just 1. So I'm going to actually write the positive 1 there. It's easier to see what's left, and then we're left with 2x. So you can see then you can take out the GCF of 2x minus 5 out of both of those. And the other factor left is x plus 1. So once you have that figured out, then off to the side here, we need to figure out what those partial fractions are going to be. So we'll start out with our x divided by, we just factored it into 2x minus 5, x plus 1. And it doesn't matter which of these you put first on your denominator. Just put 2x minus 5 first. And I'll call this one A. The numerator we're going to figure out, plus B divided by the other factor, which is x plus 1. And then the first thing you can do to wipe out all the fractions to solve for AB is multiply by the GCF, which in this case is 2. And 2x minus 5 and x plus 1. And what that does is it completely wipes out the denominator here, so you're just left with 3x minus 2 equals, on this one the 2x minus 5's cancel out, so you're left with a times x plus 1. Plus on this one the x plus 1's reduce out, so you're left with b times 2x minus 5. And now to solve this, initially it might look like, well, this is too many variables to solve for when we have one equation and 3 unknowns. So we just use a strategy to help us eliminate either the a or the b by choosing a specific x value. So let's say we left x, to eliminate the a, what would make this x plus 1 equal to 0 would be if x is negative 1. If you set it equal to 0, you subtract the 1. So let x equal negative 1. That would be 3 times negative 1 minus 2. a minus negative 1 plus 1 plus b 2 times negative 1 minus 5. And then we can simplify it, so this gives you negative 3 minus 2 is negative 5. Notice the negative 1 plus 1, that's 0 times a, so that wipes out the a term. That's what we wanted to happen. And then right here we get negative 2 minus 5, that's negative 7 times b. So negative 7b. And then divide by the negative 7, so we get b equals, the negatives reduced out, so 5/7. So now we know what b is. That's what's going to go on the numerator of this fraction. And then back to our original equation here. And we're going to choose an x value. This one's a little bit trickier, but not too much. It would wipe out the b. So here, if you set 2x minus 5 equal to 0, you'd add the 5 and divide by 2. So we've got x equals 3 times 5 over 2 minus 2 equals a, put in 5 over 2 for x here, 5 over 2 plus 1 plus b 2 times 5 over 2 minus 5. So then just simplify it to help us solve this one. So this would give you 15 over 2 minus 2. So get a common number, that's 4 over 2. 15 over 2 minus 4 over 2 is 11 over 2. Equals, here we've got 5 over 2, plus 1 is 2 over 2, gives you 7 over 2. And then here you can see the 2's reduced out, so you'd have 5 minus 5, that's 0, that wipes out the b term. And here what you can do to solve it in one step, you can multiply by the reciprocal, 2/7. And then notice the 2's reduced out, so we're just left with 11/7. So now we know the numerator that goes right here, above the 2x minus 5. So now we can take our original integral and split into these two separate integrals. Remember, with the properties of one of the properties of integrals, just like with derivatives, is when they're added and subtracted, you can integrate each one separately. You can actually write it as two separate integrals. What I'm going to do is this first integral. We figured out a is 11/7 over 2x minus 5. And then times x. Plus b is 5/7 over x plus 1. Again, times dx. And then what you can do on both of these is pull the constant coefficient out in front. Pull the 11/7 in front of this one. And then we'll just have the integral of 1 over 2x minus 5. And here we can pull out the 5/7 out in front. And now, technically, these would both require u substitution. You'd set u equal to the denominator. But there's a shortcut that comes in handy on these problems as well as some other integration problems that you can use. And that's whenever you set u equal to something where its derivative would be a constant, you can actually use the shortcut and not have to use this. So here we would set u equal to 2x minus 5. The derivative is 2. So rather than using u substitution, you can just divide by 2, or essentially multiply by the reciprocal, multiply by 1/2. And then you can integrate it just like if it was a single variable. So that would integrate the natural log absolute value of 2x minus 5, like if it was a 1 over u. And then this one, similar shortcut, except this one's even easier because the derivative of x plus 1 is just 1. In that case, you can just integrate. That doesn't affect at all. Dividing by 1 doesn't change anything, so you have 5/7. And then, again, natural log absolute value of x plus 1. And then don't forget, it's an indefinite interval plus c. So you can simplify a little bit. This just simplifies to be 11/14 on the front. Natural log of 2x minus 5, right? Plus 5/7. Natural log absolute value of x plus 1. Now, sometimes you condense further with your log properties, but not usually on ones where they have different coefficients like this. They be left separate. Ones where you would combine them would be like, for example, on the other video where here they were both 2/5. So we condensed them, factored out the 2/5, and then when they're subtracted, condensed them by divided. That's not the case. All right, so let's look at a definite integral now. This one, notice, is pre-factored for you. And the numerator is a little simpler, it's just 13. So you can say 13 divided by 4x plus 1 and 3 minus x. Let's split it up into a over 4x plus 1 plus b over 3 minus. And again, to solve this, first wipe out the fractions, multiply the whole equation by the least common denominator, which has 4x plus 1 and 3 minus x. So that would just leave you with 13 on this side. Then on this next term, the 4x plus 1's reduce out. So you're just left with a times 3 minus x. Plus here the 3 minus x is reduced out, so you're just left with b times 4x plus 1. And again, to solve this, we choose our x's strategically to help us solve these for a and b. So you can first, to wipe out the a's, set that equals 0, let x equal 3. So 13. There's nothing to substitute in on the left side. Equals a. And now 3 minus 3. Plus b. 4 times 3 plus 1. We get 13 equals 3 minus 3, that's 0, that wipes out the a term, which is what we wanted to happen. And then 4 times 3 is 12, plus 1 gives you 13b. And when you divide by 13, you just get b equals 1. So sometimes they work out to be fractions, sometimes integers, just depends on the problem. Then let's try to eliminate the b by choosing an x value that will do that. So here we set 4x plus 1 equal to 0. You subtract the 1 and then divide by 4, so that gives you negative 1/4. So 13 equals a times 3 minus negative 1/4. Plus b 4 times negative 1/4 plus 1. So we get 13 equals. So this one is 3 is 12/4. This becomes plus 1/4 gives you 13/4. Times a. And 1/4 times negative 4 times negative 1/4. The 4's reduce out. You're just left with negative 1 plus 1 is 0. So that does wipe out the b like we wanted. And then you can multiply by the reciprocal to solve for a. So multiply by 4 thirds. And you can see that reduces out the 13s here. And we're just left with a. So when we rewrite this now, this is a definite interval though. So it's going to be from 0 to 2. And the first one we figure out a is 4. And what you can do is pull that out ahead of time if you want. So we can just pull the 4 out here. So that's our next step anyway. And then what we'll be left with is 1 over 4x plus 1 times dx plus, here b was 1, so there's nothing to pull out there. So just 1 over 3 minus x. Dx, and this one's also from 0 to. Right, so and integrate each of these again using that shortcut for u substitution, since the derivatives would both be constants. Here the 4 would stay out in front. The derivative of 4x plus 1 is 4, so we divide by 4. Another way to see why that would make sense there is, remember, u substitution is kind of like the chain rule for integration. So if we were taking the derivative with 4x plus 1 on the inside, we'd have to multiply by 4. Okay? So here we're integrating, so we end up having to divide by 4. The reverse process. And then when you integrate 1 over something, you get natural log absolute value of that something, in this case 4x plus 1. Plus, here the derivative of 3 minus x is negative 1. So you would technically be dividing by negative 1 on the outside. So 1 over negative. Whoops, I forgot to put the brackets here. And integrate from 0 to 2. And then on this one, when you integrate this, you get natural log absolute value of 3 minus x. 0 to 2. So then on this one, you can see the 4's reduce out. And then we don't, when we use, normally with regular u substitution, you'd have to convert the lower and upper limits, 0 and 2, to be u values. But if you use the shortcut, since we never technically use u, we just keep it with x, then you don't convert those. You just leave them 0 to 2. So when you substitute in 2, you get 4 times 2 plus 1. That gives you 8 plus 1 is 9, so you get natural log of 9. Minus, when you plug in 0, that wipes out the 4, you just get 0 plus 1 is 1, so natural log of 1. Plus, oops, actually it's going to be minus It was plus, but because of this negative right here, it's a minus, so it's minus this whole thing. And then when you substitute in 2, 3 minus 2 is 1, so you get natural log of 1, minus, when you substitute in 0, natural log of 3. Notice here the absolute values didn't have any effect. But perfectly well, if you substitute in the lower upper limits and you get a negative number, the absolute value just changes it to positive. In this case, they're all positive. So remember, natural log of 1 is equal to 0. So both of those are 0. So all we're left with is the natural log of 9. And then if you distribute this negative, it becomes plus the natural log of 3. Now this is the right answer, but usually they'll condense these, especially on multiple choice questions, into a single logarithm using their log properties. And so remember, when two logs are added together, remember logarithms are just equal to exponents. So that same rule for exponents applies. You can condense them by multiplying. If it was minus, then you go 9 divided by 3. So that becomes the natural log of 27. So that would be your simple condensed answer into a single logarithm. And if there's a coefficient out in front, which here there isn't, then you can move it up to be an exponent to simplify it further, but here that's a plug. And that concludes the notes for AP Calculus on the topic of integration by partial fractions. Continue.